So in this video, we'll look at reflections and the two different types of reflections that we can have for functions. So we can have a reflection in the x-axis, a reflection in the y-axis. You can combine the two also. But looking at the reflection in the x-axis first, we got this point 2, 4. So if we were to reflect this point in the x-axis, and you see the x-axis is your mirror, the point therefore is going to be reflected down here. And it will be 2, negative 4. So reflection in the x-axis, you see, will have no effect on the x value, but it will impact the y value. And what happens to the y value is it becomes negative. So if we think about this in general terms again, we've got x, y, and what actually happens is it becomes x negative y. So again, we think about this point, x, y, and we find the image of that point under the reflection in the x-axis. It becomes x negative y. Again, we want to think about it using this mapping notation, which your image of your point is always what we refer to as x dash y dash. Any changes that have happened here. So we can see in the first one, the x dash, nothing has happened, it just remains the same. But y dash has become negative y. So therefore, x equals x dash and y is going to equal negative y dash. So we can think about the function here again of y equals x squared and use this mapping notation to work out what effect it will have on the function. So when we've got this function here, we've got y equals x squared. So what we're going to do is replace the x with, we'll just replace the x with x dash, which you don't use that at all, so that's just going to be x squared. But what we do is we replace the y with negative y. So therefore, if we rearrange this to make y the subject, it's going to be negative x squared. So you'll see that the minus, that's what the function is going to be. So then to check what the point is, we can say that when x equals 2, make sure that this 2 minus 4 lies in our new function. Y is going to equal minus 2 squared. We do the indices first and then subtract, so that will be minus 4. And that point will lie on our function. So when we're going to use function notation to work this out, we've got the function f of x. If we then do a reflection in the x-axis, and think about it here, it's the y value that became negative, and another way of saying y is f of x. So therefore, this is why put the minus outside the function as we did here. So the function you see was f of x equals x squared. When you reflect it in the x-axis, it's going to become negative x squared. So let's have a quick look in the y-axis now. Look at this point 2, 4 again, and if we reflect this in the y-axis, the y-axis is going to be the mirror, so this point will be reflected here. So it will actually become minus 2, 4. So in general terms again, starting off with x, y, and then what's happening with this reflection in the y-axis is it's actually the x value becomes the negative, and the y value doesn't change. So then we can look at it using mapping notation as well. Remember, this is the image of the point under the transformations. It's going to be x dash and y dash. Therefore, we can say that x dash is equal to negative x and y dash equals y. What we always want to do then is make x and y the subject. So x will be negative x dash and y will just stay as y dash. And therefore, if we want to see, so again, we can think about this function here. Y equals x squared, and see what the function, what effect that this function is going to have by if we reflect it in the y-axis. So if we've got y equals x squared, we're going to replace y with y dash. So forget about the dashes once you sub it in. But we're going to replace x with negative x dash, so just negative x. And you'll see what happens here is because you're squaring a negative, it's going to have no effect, and that should make sense from the graph as well, that when you reflect this section here will be reflected here, this section here will be reflected there, so to all intents and purposes it will have no effect on the function, and we just make sure that when x equals negative 2, y is going to equal negative 2 all squared, which is going to be 4, and that transformed point will lie on your transformed function. So we'll see from this, when you do a reflection in the y-axis, your f of x, what you always do is the x value that changes. Therefore, when you do a reflection in the y-axis, you replace x with negative x.